Okay, so this is lesson 3.3. And what we're talking about in this lesson is proving trig identities. So we simplified trig identities. Yesterday we used trig identities to solve equations, and now we're going to prove them. So these are the general steps that we will use. So step 1, simplify only one side of the equation until it equals the other side. It is usually easier to start with the more difficult side of the equation. Consider converting everything to sine or cosine. If fractions are present, consider getting common denominators. Okay, so let's look at the first one. This is not a trig identity. This is an algebraic identity. So remember me telling you Thursday, an identity is an equation that's true for any variable. So I could put any number in this equation. The left-hand side, once I simplified it, would be 2. Except for two numbers. What are two numbers I could not use? 1 and -1, because it would make them undefined, right? Other than that, any number would make this equation true. So what we're going to do is prove that this stuff on the left actually does equal 2. Okay, so look at my suggestions. Simplify only one side and start with the more difficult side. The reason we're going to start with the more difficult side is, what if I said we're going to make 2 become that? Like, where would you even start? I don't even know. So the more complicated side, you just have more to work with, and we're going to simplify this left-hand side until it becomes 2. So you know when to stop on these. As soon as I get the left-hand side to be 2, I'm done. Okay, so we're going to whittle away at the left-hand side. What can I do to simplify the left-hand side? Get common denominators. Okay, the denominator would need to have x minus 1 and x plus 1 in it. So, actually I see some other option. Do y'all see anything? And do not tell me, don't tell me you're going to cancel some x's and 1's. Factor. The numerators are both difference of 2 squares. Nice. Okay, so the left-hand side, I'm going to, I'm glad we saw that and didn't get common denominators. I'm going to factor both of these numerators. Difference of 2 squares, nice and easy to factor. 1 plus, 1 minus, other than that, they're identical. And a term from Algebra 2, those are conjugates of each other. You talked about conjugates when you talked about imaginary numbers. Okay, I have a common factor of x minus 1. Cancels. I have a common factor of x plus 1. Cancels. So what's left is x plus 1 minus, now I've got to put that x minus 1 in parentheses and subtract both of those. So that's x plus 1 minus x plus 1. And what does that equal? 2. So we got 2 equals 2. We know when to finish these. Both sides are equal to 2. And we're done. Luke, what's wrong? Never mind? All right. Any other questions? Okay, y'all hang on. Sit tight 1 second. Next one. This is it. One little page here. Okay, so this one we are going to prove that sine equals tangent over secant. Okay, so it's not a question of does sine equal tangent over secant. I'm telling you they are equal. We just have to manipulate it to prove it. So which side would you consider the more complicated side? The right. So we're only going to simplify the right. We're going to leave the left alone. We will be finished when we turn the right side into sine. Okay? So what do you think I'm going to do to this side? Yeah, let's switch everything to sine and cosine. All right, so tangent becomes sine over cosine. Secant becomes what? 1 over cosine. And then we're going to do a little keep, change, flip, or shortcut. I'll set up keep, change, flip. Keep the first one, change to multiplication, flip the second one, in other words, multiply by the reciprocal. And then any common factors, this has to be multiplied to be a factor. Common ones cancel, and I have sine x, and that's exactly what I wanted. I wanted to show that it equals sine x, so we are done. Not too bad. So like we did last week, but now you know when to stop. Okay, now this one's a little tricky in that what do you think is the more complicated side? Think of which one you have more to work with. I would think the left. The right I could change to 1 over cosine, 1 over sine, but that's not going to be that, is it? So let's work with the left, and let's see if we can get it to equal secant cosecant. All right, so tangent plus cotangent, that's not a Pythagorean identity or anything like that. So I'm going to go back to that rule, change to sine and cosine. Okay, so I'm totally leaving the right side alone, but when I get secant, cosecant, then I know I'm done. Okay, next, what can I do with two fractions that don't have the same denominator? Yeah, get common denominators, right? So each one will have to be multiplied by the other. So my denominator needs to have sine and cosine in it. So sine over sine, multiply on the left. Cosine over cosine, multiply on the right. Alright, so that gives me sine squared over sine cosine plus cosine squared over sine cosine. What can I do with that next? Once you have common denominators, then you can smush it into one fraction, right? Very technical term, smush. But what is sine squared plus cosine squared? 1. Okay, now keep in mind what I'm trying to prove. Secant, cosecant. Do you see where I'm going to get there? Okay, I can split this into 1 over sine times 1 over cosine, can't I? If I multiply that, then that gives me that. Well, 1 over sine is cosecant, and 1 over cosine is secant. Now, it doesn't matter which one I write first because multiplication is commutative. So there we go. I produced what was on the right-hand side. Question on that? All right. Example 4. Which side should we tackle? Left. I think I probably agree with that. What can I do with cosine squared minus 1? All right, let's check out those identities. What is cosine squared minus 1 equal to? Be careful. Negative sine squared. Are we okay with that? Any no's out there? Okay, let me go through it just for those who might be unsure. Okay, so I have sine squared plus cosine squared equals 1. That is my first main Pythagorean identity. But I have cosine squared minus 1. Okay, so let's subtract 1. Now I have sine squared plus cosine squared minus 1 equals 0. Well, I want to replace cosine squared minus 1. I want this to be by itself. So I'm going to subtract sine squared. And that gives me cosine squared minus 1 is negative sine squared. Okay, so I'm going to replace negative sine squared A over cosine A. Okay, look what I want it to be equal to. Negative tangent times sine. How am I going to get there? Okay, I'm going to break this down. Okay, there's the negative. I have a negative, so that's all good. Tangent is sine over cosine. And then sine, I'm going to write as sine over 1. Do you see how those are the same? I have negative sine squared over cosine. Well, this is negative tangent. And that's sine. So I've got the other side done. Okay. Okay, do we agree that the left is the complicated side here? What are we going to do? I think we're going to have to get common denominators. So, let me just write these down. Okay, what's my denominator need to have in it? 1 minus cosine and 1 plus cosine. So each needs the other denominator. So 1 plus cosine over 1 plus cosine. So this is not an equation. I can't just multiply both sides by a quantity because it's not an equation. So I have to multiply by quantities that equal 1. That's why I'm multiplying top and bottom. Okay, multiply these two fractions. 1 times 1 plus cosine is 1 plus cosine. Over, should we FOIL that out? Maybe in the next step. I'll just bring it down for now. 1 times 1 minus cosine is 1 minus cosine. Okay, do I want to cancel these common factors? Why? If I cancel those, I'm going to go right back to what I started. It's like an endless loop that I can't get out of, like a hamster on a wheel, right? Like, don't cancel, because then we go right back to step 1 again. So leave them as is. Let's combine them into one fraction. So that's 1 plus cosine minus 1 plus cosine over denominator. Do you see why it's plus cosine out here? It's basically this negative is distributing to both. So that's minus 1 but plus cosine. Okay, do I have like terms? Yes, I do. 1 minus 1 is 0. What is cosine plus cosine? What's x plus x? 2x. So what's cosine plus cosine? 2 cosine x. Nice. Okay, I'm going to stop and see what I'm trying to get after I write this down. See what I need to do next. Okay, I'm trying to get 2 cotangent cosecant. Well, I have a 2, so I'm definitely on the right track. How can I turn this into cotangent cosecant? I think we should probably distribute this out. If I distribute that, what will it become? Okay, so 1 minus cosine squared? Okay. But look back at what I need. There's no 1 minus something. But what is 1 minus cosine squared the same as? Sine squared Okay, look back. I need 2 cotangent cosecant. So I'm going to do something similar to what I did 2 problems above. I'm going to write this as 2 cosine over sine times 1 over sine. So I'm just breaking this down into these 2 fractions. And cosine over sine is cotangent. 1 over sine is cosecant. So I have 2 cotangent cosecant. That's what the other side had. We are done. Question. Not terribly bad? Alright, that's it for the notes. So let me get your homework to you, and you've got loads of time.